Geometry guys, welcome to our first installment of our first semester exam review. In this chapter 1 review, you're going to see about 5 or 6 problems, and you can go through these. I'm going to have you answer some questions as you're going through this, so make sure you get your notebook out or a sheet of loose leaf, and you're going to work some problems on your own as well. At some point on the semester exam, you're sure to run into an intersection problem, a union problem, or one of each. Remember, the key word when we talked about a union was everything, and when we talked about intersections, we were talking about the key word points in common or overlapping. So let's take a look at our first problem. We're going to look at the ray KA in union with the ray KB. The first thing we want to do is trace ray KA, and notice I'm not exactly on the line, but that's good enough. And now I'm going to go ahead and I'm going to use a different color to trace over ray KB. Again, not exactly on the line, but close enough. Note the importance of arrows going in both directions because they are both rays. And then the question again you're going to be asking yourself is, what does union mean? And of course it means everything. So we are going to be counting everything on the red ray and everything on the blue ray, and we put the two rays together, we form a straight line. Now the line can be named a number of different ways. You could call it line AK, line AB, line KB, line BA, a number of different things. I'm just going to call it, for the sake of keeping things simple, line AB. Note the arrows going in both directions. It is extremely important that we have the correct symbol above the AB. Now, moving on to the second question, we've got actually the same two rays. I'm going to, again, trace over ray KA in red, and it goes all the way to point K, which I've made a point there. And then, of course, we still have the ray KB in blue, and you can see me, I'm just making a point where the K endpoint is. Now, when we talk about intersection, we're talking about overlapping or points in common. So you should be asking yourself, where do the blue and the red overlap, or what points do they have in common? And hopefully it's very clear the only place they overlap, or the only point they have in common, is point K. So that is going to be our solution. Now, on your piece of loose leaf, I'd like you to find the answer to both question 3 and question 4. Moving right along, we're going to now look at a clock problem. Now, there's a couple key things that we need to remember when we're talking about these clock problems. First off, I can, label maybe hour 12, hour 6, hour 3, hour 9. I'll fill in some more numbers here later. But I want you to remember a couple things. First off, there are 360 degrees in a circle. Secondly, since there are 12 numbers that go around the clock, in between each number is 30 degrees. So if I were to just draw an angle that looked like so, and the hand was exactly on the 12 and exactly on the 1, that would be a 30-degree angle. We have to keep that in mind as we go through this problem. Now, the first problem we're going to look at, it is 7:15. So, of course, we are going to include the numbers 7 and 8 for this problem. And, of course, we're going to have the big hand pointed right at the 3, 15 minutes past the hour. Now note, the small hand, it's not going to be exactly on the 7, it's going to be somewhere between the 7 and the 8. Now, even though it's a shorthand, I'm going to make it nice and long so we kind of see what we're doing here. Go ahead and add the 4 and the 5, and then we'll continue on with our problem. Let's continue on with the easy part. We know for a fact that there's 30 degrees between the 3 and the 4, 30 more degrees between the 4 and the 5, 30 more between the 5 and the 6, and 30 more between the 6 and the 7. So if we take all these numbers and add them up, we have 120 degrees. The only thing that we really have to figure out is the measure of this angle between the 7 and the 8. It's not 30 degrees because we have not gone all the way to the 8. We've gone 15/60ths of the way between the 7 and the 8. So what we need to do is we need to figure out what 15 over 60 reduces to. Well, 15 is 5 times 3. 60 is 5 times 12. And actually, the nice thing is here we can reduce 3/12 to 1/4. So we've gone a quarter of the way between the 7 and the 8. Well, if there's 30 degrees between the 7 and the 8, a quarter or a fourth of 30 degrees is 7.5 degrees. So we've gone 120 degrees from the 3 to the 7, and then another 7.5 degrees from the 7 to the 8 to give us a grand total of 127.5 degrees. Now, this gives a lot of guys a lot of troubles. I want you to attempt the second problem. On your sheet of loose leaf, figure out what the angle is at 640. 640. Next up, we are going to look at a trisect and bisect problem. I think one of the biggest mistakes guys make is that they try to put the trisection and bisection together. Really, I want to treat this as almost two separate problems. First problem we're going to be looking at, we have a trisection. B and D trisect AE. Don't even look at the second piece of given information yet. We're not going to use it. So what that means is B and D are going to cut line segment AE into 3 equal parts. Now the first part we need to figure out here is how long is the line segment AE? Well, from -6 to 12 is going to be 18 units. In this problem you can see I actually have ordered pairs. The zeros really are not relevant. All that tells us is that we have a horizontal line, x coordinate being -6, 0 for A, E has a coordinate of 12, 0, and the y coordinates are going to be 0 for all of our points. Horizontal line. So moving right along, B and D trisect AE. Trisect means divide by 3. What are we dividing by 3? The length of that segment, 18. 18 divided by 3 is 6. What that tells us is the distance from A to B is 6 units, from B to D is 6 units, and from D to E is also 6 units. Notice, my diagram is not drawn to scale. It does not look like those 3 parts are equal. A, B, B, D, and D, E. Doesn't look like it, but they are. So the first part of this is figuring out what's the coordinate of B. To find that, I have to add 6 to -6, and I get 0, 0. To find the coordinate of D, again, I'm going to add 6 to 0, and I'm going to get 6, 0. And those are my coordinates B and D. Next up, C is the midpoint of AE. C, which I'm marking on my diagram, is the exact middle point of AE. And we know the distance from A to E is 18. If I cut that in half, we know it's 9 units from A to C. So if I take -6 plus 9, my coordinate C is going to be 3, 0. And what you've noticed, we've just answered part A to our question. Find the coordinates of B, C, and D. You can see those listed. Next up, we are going to find the length of BE. I want to know how long is it from this point B all the way to this point E. Well, we're going from the coordinate 0, 0 to 12, 0, which is going to be 12 units. Last part of this, our angles 1, 2, 3, and 4 congruent. I just added those numbers in right now. Hopefully you are not going to jump to conclusions and think that those 4 angles are congruent. I tricked a lot of you on Chapter 3's test when I asked you that question, and I've asked it multiple times this year. The answer is not yes, not no. We don't know. just because a segment is trisected or bisected does not tell us anything about the angles. So do not assume that 1, 2, 3, and 4 are congruent angles. In this particular problem, we're talking about really two topics: factoring and knowing what an angle bisector is. An angle bisector is pretty straightforward. If in the given information we are told a ray bisects an angle, we know for a fact that we are cutting one larger angle into two equal smaller angles. So, to set up an equation here, I know that 12x minus 5 is equal to x squared plus 6x. That's a fact. Note, I'm trying to find eventually angle ABD, which I'm coloring in blue, the 12x minus 5 degree angle. Now, when you're factoring, very, very important, we must set one side of our equation equal to 0. So I'm going to leave x squared on the right side, and I'm going to bring this 12x and 5 over to the right side. So my 12x minus 12x cancels, negative 5 plus 5 cancels, and I get 0 equals x squared. 6x minus 12x is minus 6x plus 5. Now, factor. You can leave the equals 0 part, x and x. What are the factors of 5 that add up to 6? Well, how about this? 5 and 1. What are the signs going to be? Hopefully you understand, since our middle term is negative and our last term is positive, we're going to have a minus sign. So we're not done, because we need to answer the question that was being asked. We factored, but we have to do more. So since 0 is equal to x minus 5 times the quantity x minus 1, we know that x equals 5 or x equals 1. Now when we plug that back in to our angle ABD, which is what we are being asked, we are going to take 12x minus 5 and figure out what that value is. So we're going to take 12 times 5 minus 5, which is 55 degrees. And we are also going to take and see if the 1 will work as well. 12 times 1 minus 5 equals 7 degrees. Both answers need to be included. Our angle is either going to equal 55 degrees or 7 degrees. On the test, maybe I would ask you for the angle ABC. On your piece of loose leaf, tell me, what is the measure of angle ABC? The last two problems we have are going to be systems of equations problems. Remember what a system is. They are problems where we have two variables, x and y. Now, in order to solve a system of equations, we have to have two equations. Two variables, two equations. That's what's going to make up our system. Note, straight line, 180 degrees. Therefore, we're going to take 15x plus 25y plus 80 plus 15x plus 20 and set that equal to 180. Combine like terms. 15x and 15x gives us 30x. 25y has no like term, so we're going to say plus 25y. Plus 80 plus 20 is plus 100 equals 180. Now at this point I'm going to subtract 100, and I'm going to have a nice neat equation written: 30x plus 25y equals 80. Now I need to get my second equation. No problem. In my second diagram, we have a right angle. Therefore, 30y minus 15x plus 45 equals 90 degrees. Perpendicular, right angle, these two angles add up to 90 degrees. Again, I'm going to combine like terms, but here we really don't have like terms. So I'm just going to put these terms in the proper order. Negative 15x first, plus 30y, and then I'm going to subtract 45 from each side, and that's going to equal 45. Now, here's where organization comes into play. I'm going to take that blue equation, and I'm going to line it up right below my green equation. Negative 15x plus 30y equals 45. At this point, I'm looking at the coefficients in front of my variables. The x's have coefficients of 30 and negative 15. The y's have coefficients of 25 and 30. Remember, we need opposite coefficients. In other words, if I have a 30 in front of my first x, I need a negative 30 in front of my second x. That's going to be the easiest thing to do here, since the y's do not have opposite coefficients. So I'm going to take this second equation and I'm going to multiply it by 2. Notice, when I multiply by 2, I have to multiply by distribution. 2 times negative 15x is negative 30x. I'm going to multiply the 2 times 30y, which gives me 60y. 2 times 45 is 90. Now, I am no longer in need of my blue equation. The blue equation and the gray equation are equivalent equations. I'm just going to use the gray and the green. At this point, we are going to add the gray and the green together. We see 30x minus 30x is 0, so I'm going to cross that out. 25y plus 60y, I'm going to write that down over here. 85y equals 80 plus 90, 170. Now I have one variable, one equation. I'm simply going to divide by 85, and bingo, y equals 2. At this point, we need to solve for x. The question's asking us for both the x and y value. So I have a number of different options. I can plug in y equals 2 into my green equation, which I just circled, my blue equation, or my gray equation. It doesn't matter. I can plug it in anywhere. Just because this would give me the most organization, I'm going to plug it into this blue equation, which I'm pointing a big arrow to. So, negative 15x plus 30 times 2. y2, because we established down here y equals 2. Substituting that in, that's going to equal 45. So negative 15x plus 60 equals 45. Again, now I have one variable, x, and one equation. Easy to solve. Subtract 60 from both, and I get negative 15x equals negative 15. Therefore, x equals 1. My answer, as an ordered pair, which I'm going to write in the upper left-hand corner here, is 1, 2. Now, I want you to figure out part B. Find the measure of angle ABD. It should be pretty simple. You're just going to punch in the x and y values that we just found. Do that on your loose leaf. This is another example of a system. I'm not going to go through this entire problem like I did the last one, but just know, even though it's a little bit different looking diagram, it's the exact same type of problem. In fact, in this problem, we can write 3 equations to solve for our variables x and y. I don't want to do that. I'm only going to write 2 equations, but potentially I could write 3. The first equation, I could add up those 2 angles to equal up to 180 degrees because this is a straight line. The second equation, I could actually add up these 2 angles to equal 180 because this line is also a straight line 180 degrees. The third equation I could write would be 4x plus y plus 10 equals 6x minus y plus 20, because this angle here and this angle here are vertical angles. So you need to choose any two out of the three angles of your choice, excuse me, not angles, two out of the three equations of your choice, and solve the system. Do that on your loose leaf, and then find the measure of angle alpha. Alpha is this variable right here.